In this video, we are going to see 11th grade, chapter 13, math syllabus, that is limits and derivatives. Specifically, I completed around 16 questions in exercise 13.1. So let me start to explain each questions. So first question is limit x approaching 3 x plus 3. So here it looks very direct substitution, x equal to 3. So you just substitute x equal to 3, which gives you answer 6. So for a couple of problem, I try to explain how the left limit and right limit work. If you see the horizontal chart which is given below, where I mentioned the x value which varies from 2.7 to 3, randomly I choose some values as a left limit, and on the right limit you can see that the value changes from 3.1 to 3.3. So when we are substituting the x value, what value we are getting as f of x? F of x is given as x plus 3. So you can see here the value between 2.9 and 3.1, which falls the x approaching 3. So when x approaches 3, the answer would be 6. So it's pretty right, the left limit when the x value is 2.9, the y value, that is f of x value, is 5.9, and when the x value is 3.1, the f of x, that is y value, is 6.1. So the x approaching 3 falls between 2.9 and 3.1. That's why I have elaborate a little bit in this below chart. Okay, let us move on to the second question, that is limit x approaching 5. Here x is not equal to 5, it's like x is approaching 5, so it's not exactly x equal to 5 pi value. So you should have a little bit clarification in this point. So x minus 22 by 7, so again this is 22 by 7 is a pi value, approximate value. So limit x is approaching 5 pi, so pi, which is 22 by 7 minus 22 by 7, this is equal to 0, and this exists, the limit exists at 0, because when you are seeing the left limit is 0.5 and right limit is 0.5, so the 0 minus 0.5 to plus 0.5, and the values 0 falls in between minus 0.5 and plus 0.5. That's why it's 0, it exists at when the limit x approaching pi. The third question, limit r approaches 1, it is a pi r square. So here I'm just giving some explanation with the horizontal graph here, x and f of r. So f of r is the whole function and r is a value which is approaching 1, so which approaches the negative, from the negative limit is 0, 0.51, and the positive limit would be 1.5 and 2. So when we are substituting the r value for the corresponding f of r, we can find some values. So when x approaching 1, when r approaching 1, the f of r would be 3.14, so which falls in between 0.7 and 7.06. so limit exists at 1. All right, simple. So fourth question is when limit x approaches 4, so 4x plus 3 and x minus 2, which is falls as f of x function. So here also I substituted the left limit series, that is from 1.9, 1.9 to 1.96, and the right limit series, that is 2.06, 2.08 and 2.09. So when we are substituting the left limit and left limit, the value of 4, when x approaches 4, the f of x would be 2, which is falls between 1.96 and 2.06. So this limit exists and the answer would be 2. Question number 5. When x approaches minus 1, that is, the given function is x to the power of 10 plus x to the power of 5 plus 1 divided by x minus 1. So here also I gave some random value for the negative limit as well as for the positive limit. So negative limit, I choose some random value from minus 0.95 to 0.99, and the positive limits from minus 0.05 to minus 1.09. Alright, so when we are substituting the corresponding value for f of x, we found that minus 0.5 when x approaches minus 1. Exactly. So this is the answer, which is when a limit x approaches minus 1, the corresponding value would be minus 0.5. Question number 6. Here is the game starts. When limit x approaches 0 to the function x plus 1 to the power of 5 minus 1 divided by x, and when we are substituting the x value, randomly I choose to substitute from minus 0.98 to minus 0.99, and the positive value is 0.1 to 0.12. So when we are substituting it, it approaches 0 by 0 value. So when a limit says it's 0 by 0, it defined as indefinite function, which means that there is no limit exists at that point. But it's a responsibility of us to simplify the existing function to find the exact value which is appropriate for this limit, which is x approaching 0. So below I try to simplify the given problem, that is, so by using a formula x to the power of n minus a to the power of n divided by x minus a equal to n into a n minus 1. A simple equation. So I'm just adding and subtracting minus 1 and in the denominator here. So okay, just doing it, and when I did it, I found that the given expression matches the formula that I mentioned earlier. So substituting n corresponding n and a value, we found the answer would be 5. Question number 7 in the exercise 13.1, it states that limit x approaches 2, the given expression is 3x square minus x minus 10 divided by x square minus 4. So as I told you earlier, we need to simplify this function. So without simplifying, and directly if I substitute x approaches 2 or x equal to 2, you can see that it will attain a value 0 by 0 again, which falls as indefinite function. So as I told you earlier in the previous problem, it's our responsibility to simplify the existing function. So I use a factorizing method which we learned in our previous class, in our previous grades. In 10th grade, if you could go back and check the subject, you would learn the factorizing the existing function, existing algebraic function. So 3x squared, so right side I mentioned it, when you are multiplying the first and last value, that is 3 into 10, which gives you 30 minus 30, and when you are adding, it must give minus 1, which here it's mentioned as minus x. So the right number would be minus 6 into 5, which is, when you are multiplying, it give minus 30, and when you are adding, it give minus 1. Alright, so I'm just taking 3x as a common value here, so it will provide x minus 2 plus 5 as a common, and it will give you x minus 2. So keeping below x square minus a square formula, which is x minus a into x plus a. So, and I am substituting the value there. X minus 2 are getting cancelled, and once it got cancelled, now you should substitute limit x equal to 2, which gives you 11 by 4. Question number 8. Limit x approaching 3 to the function x to the power 4 minus 81 divided by 2x square minus 5x minus 3. So when we are directly substituting 3 here, again it will gives you a value 0 by 0, which is an indefinite function. Again we need to simplify this function. So simplifying that, x square minus 9 into x square plus 9. So again a to the power n minus x to the power n minus a to the power n formula here. Simplifying the denominator, 2x square minus 5x minus 3, so it should be minus 6x plus x. When you guys are simplifying it, again I am breaking the existing function, that is x square minus 9 as x minus 3 x plus 3. So taking 2x as a common in denominator, which will gives you 2x minus 3 plus 1 as a common, and x minus 3 cancelling the corresponding similar functions. Now you are substituting the limit x approaches 3. Once you put it in the right place, you can find an answer 108 divided by 7, which is very simple. So here one thing is very common, we need to simplify the existing functions. So here we go to the 9th question, which says that limit x approaches 0 in the given function ax plus b divided by cx plus 1. Here it looks very simple and you can use a direct substitution. When we are directly substituting x equal to 0, which gives you 0 plus b plus divided by 0 plus 1, which again gives you b. Very simple. So wherever the function says which gives you answer simply because of direct substitution, that's it, very simple. If it's not showing the value that much easy, then it's a responsibility of each and every students to simplify the existing function until to find a perfect value for the given limit. So the next question would be given as limit z approaches 1, so to the z to the power of 1 by 3 minus 1 divided by z to the power of 1 by 6 minus 1. Here also, when you are directly substituting 1, it will gives you 0 by 0 in definite form. So we have to simplify here. Simplification is very simple here because we already saw in the previous question that formula, that is x to the power of n minus a to the power of n divided by x minus a, which gives you n into a n minus 1. So here once you are substituting or finding this formula, you have to make the existing equation into the form of that particular formula, for which what I'm doing is that I'm dividing and multiplying z by z minus 1. So here you can see in the below steps, that is z minus 1, I'm multiplying and dividing, so that we get a form that says that for the first equation, which is falls as n is 1 by 3 and a equal to 1, and substituting the particular value there. And the next set of equation which says 1 divided by z to the power of 1 by 6 minus 1 to the power of 1 by 6, and it's which is again comes as 1 divided by 1 by 6 into 1 and 1 by 6 minus 1 to the power. So when we are substituting the respective value and simplifying it again, we get an answer which says limit z approaches 1 equal to 2. It's very simple. Okay, so the next question is 11th question, which says that limit x approaches 1 to the given function ax square plus bx plus c divided by cx square plus bx plus a. So here they have given that a plus b plus c is not equal to 0. So just when you are substituting directly 1 put to the both side, so to the numerator and denominator, you can find the answer 1, which is very direct answer, simple. Question number 12 says that limit x approaches minus 2 to the function 1 by x plus 1 by 2 divided by x plus 2. So directly when you are substituting x equal to minus 2, that gives 0 by 0 form. Here we need to simplify the equation. Okay, by taking LCM for the numerator, and once you did that, you can find that the equation transform into 2 plus 6, 2 plus x divided by 2x into x plus 2. So once it approaches this value, you are directly substituting x equal to minus 2. So moving to the question number 13, which says that limit x approaches 0, sin ax divided by bx. So when directly substituting x equal to 0, sin 0 is 0 and bx b0, b into 0 is 0, that is 0 by 0 form. Here again we need to simplify. So to simplify it, we learn a simple formula in our previous trigonometry chapters, that is, which says that sin ax divided by ax, which gives you answer 1. So that same thing I'm doing here. I'm multiplying and dividing ax to this expression. So when I did that, sin ax divided by ax became 1, and the remaining function which exists, which is given in the below line, which says that limit x approaches 0, 1 by bx into ax, where x and x are getting cancelled, and limit x approaches 0, which gives you a by b. Simple. Okay, moving to the question number 14, which says that limit x approaches 0. Here sin ax divided by sin bx, where it mentioned very clearly a comma b is not equal to 0. When we are substituting 0 in the x place, which says that 0 by 0 form, so you have to simplify it again. We are using the same problem, the same formula as I mentioned in the previous problem. So multiplying and dividing by ax, and in the next expression I'm taking separately, sin x, sin ax I'm taking separately, and 1 by sin bx I'm taking it separately. When I took sin x separately and multiplying dividing by ax, and the second set of function where bx multiplying and dividing bx on top and bottom, which will gives you sin ax by ax is equal to 1, bx by sin bx is equal to 1, because 1 by 1 is 1, so 1, which will clearly gives you an expression which says that limit x approaches 0, x divided by bx, where x and x are getting cancelled, and the final answer will be a by b. Very simple. Here we are taking some trigonometric function and simplifying it. Moving to the next question, question number 15 from the exercise 13.1, says that limit x approaches pi and sin pi minus x divided by pi into pi minus x. So once you are substituting pi direct value, it will give you 0 by 0 indefinite function. But we have in the previous formula, as I mentioned you earlier, which is sin a divided by a, which is gives you 1. The formula, it's a formula. So here I am taking one pi as a common value outside from the given expression. It says that 1 by pi, and limit x approaches pi, which gives you sin pi minus x divided by pi minus x, again 1. The final answer would be 1 by pi. Simple. So moving to next question is 16th question, which is the last question for this video, which says that limit x approaches 0, cos x divided by pi minus x, where cos 0 is equal to 1, which is a direct substitution here. So you can directly substitute cos 0 equal to 1. So 1 by pi is the final answer. So please subscribe to my YouTube channel. In the next video, we are going to see the next set of 16 questions. Totally we have 13 questions, I think so, in the exercise 13.1. So we will see next 16 question in next video, and share this video with the with some school students who really want to learn limits and derivatives and solve the problems in the exercise 13.1. Thank you and see you in next video.